everyone, I'm going to try to do a walking talking mock with you, um, and so I'll give you instructions further on to explain what to do. So this is for the chemistry foundation paper, and this is a 2018 one. So if you grab a piece of paper and a pen, we're going to go through the questions. I want you to pause it, answer it, and then I'll review with the mark scheme and explain different things about it. Okay, so first question is this question is about structure and bonding. Figure 1 shows part of the structure of calcium oxide. What type of bonding is present in calcium oxide? Please pause your video and answer the question. Right, so to answer this one, look at the wording. We've got calcium oxide. It is a metal, calcium and oxygen, a non-metal. So that is your hint that it is ionic bonding. You've also got ions. Remember, ions are particles that have lost or gained electrons, and in this case, your oxygen have gained 2 electrons, 2 negative electrons, they've become 2 minus, and your calcium have lost 2 electrons, so they become 2 plus. If we look at our mark scheme and just scroll down, it's going to say very quickly ionic. Okay, next question. We've got this shows a particle of methane, CH4. What type of particle is present in figure 2? Please pause your video. Okay, so if we have a look, we've got carbon and hydrogen. So you've only got non-metals. I know hydrogen sometimes is on the left-hand side on some periodic tables, but imagine it is a non-metal because it's not a metal, it's a gas. It's got a low boiling point. So it's just made of non-metal. So we know it is covalent, but that's not any of the answers. So an ion we can eliminate. It's not got a charge, so it's not an ion. A lattice, it's not got a very large structure of alternating oppositely charged particles. So it's not a lattice. A molecule potentially could be, and a polymer. So molecules and polymers are simple molecules or simple covalent structures. Polymers are long repeating units, or it shows a repeating unit with a little n. So for this one, your answer is a molecule. Next question, 1.3. This shows the structure of C60. So this is a I'm just going to read it, sorry. Complete the sentence. Choose the answer from the box. The structure C60 is. Pause your video. Okay, so our answers, we've got diatomic, which means it's got 2 molecules within it. So like Cl2, F2, O2, N2, they're all diatomic molecules. So this one's got 60, so we can eliminate that. Giant ionic, now it's only made of carbon, and carbon is a non-metal, so it's not going to be ionic, because remember you need a metal and a non-metal. A fullerene is a type of giant covalent structure, so potentially could be that, and giant metallic, so it's made of carbon, not a metal, so it's not giant metallic. So this one is a fullerene, and its actual name is Buckminster fullerene, and it contains 60 carbon. Next question. Figure 4 shows the structure of graphite. What type of bond is labelled A in figure 1? Please pause your video and answer. Okay, so figure 4, it doesn't say what it's made from, but graphite, if you remember, it's an allotrope, which just means it's a different structure of a carbon molecule, of carbon. So between those 2 structures, so A is between 2 carbon, so it's the bond between 2 non-metals. If we look at covalent, it potentially could be covalent. Double, there's no double line between them, so it doesn't represent that 2 electrons are being shared from each atom. Ionic, again, there's no ions, there's no charges, there's no metal, so we can eliminate ionic, and we can eliminate metallic because it's not made of metal. This is you realizing that graphite is made of carbon. So the correct answer for this one is covalent. It's a very strong covalent structure between the atoms, but later questions might ask you between the molecules, and they're called weak intermolecular forces. In graphite, each carbon atom forms bonds with other carbon atoms as shown in figure 4. How many electrons does one carbon atom use to form one bond? Please pause your video. if we have a look, you can literally just count. So forget the end one, the edge ones, because imagine this is a much larger structure. If we look at this one, it's got 1, 2, 3. So it's just got 3. Carbon is in group 4, which means it wants 4 bonds. So later questions might ask you about what happens to that extra electron that isn't being bonded. So the correct answer for this is 3. Okay, we've got an electric current is passed through copper. Figure 5 shows the apparatus used. Complete the sentence, choose the answer from the box. So we've got copper, we've got a power supply, and we've got a filament light bulb. So you've got a circuit. Figure 5 shows that copper conducts electricity as a. Now, the fact is, it lights up. Please pause your video and answer. Okay, the fact that it lights up is going to tell us that this copper, therefore, has completed the circuit, which means it's a good conductor. So good conductors, gases are very poor conductors. So, for example, if there's an electrical fire, they sometimes flood an area with argon gas, which is inert, which stops any electricity passing. Liquids, water can, or certain liquids can conduct electricity. We know this from electrolysis, but this question tells us that copper is actually a solid. Complete the sentence. Choose the answer from the box. Copper conducts electricity because of the movement of delocalized. Please pause your video. It's movement of delocalized electrons. Remember, electricity is the movement of electrons, or current is the flow of electrons of charge. 1.8, figure 6 shows the apparatus used to investigate the effect of electricity on sodium chloride solution. So we've got, again, our filament light bulb lights up. We've got sodium chloride solution. Please complete the sentence. Choose the answer from the box. Figure 6 shows that sodium chloride conducts electricity when. Please pause your video. Conducts electricity when it is, we've got dissolved, gaseous, or molten. Now it says sodium chloride solution. So it's not molten because it's in a solution, which means it's been dissolved in water. So it shows sodium chloride conducts electricity when it is dissolved. The gas might throw you for gaseous, but it's the fact it says there a solution. So this is a solution. Question 1.9. Sodium chloride is made up of ions. Figure 7 shows the apparatus used to investigate the effect of electricity on solid sodium chloride and molten sodium chloride. We've got here, filament light bulb does not light up, and here, filament light bulb does light up. Draw one line from each statement to the correct reason. Please pause your video and answer. So we've got statement, solid sodium chloride does not conduct electricity. And if we go to it, the light bulb, filament light bulb on the left does not light up with solid sodium chloride. Our reason for that, we've got ions are fixed, ions are mobile, ions are neutral, ions are vibrating. Ions are neutral is just a random one they put in there, so eliminate that. Ions are vibrating just tells you the properties of a solid particle. So we've either got these two are the ones we're probably going to be using. And it can't conduct because the ions are fixed. In molten sodium chloride, however, it does conduct, and this is because the ions are mobile. It just means the ions can move, the ions can flow. So the two scenarios when ionic substances can conduct are when they are molten or when they are dissolved in solution. That was question 1. Question 2, this question is about the halogens. Which group of the periodic table is known as the halogens? Please pause your video and answer. The halogens are found in group 7. Group 1 are the alkali metals, so it's not that. That's lithium, sodium, potassium. Group 2 are known as the alkaline earth metals, so it's not that one. And group 0 are the noble gases like helium, neon, argon, krypton, xenon. And this one. Okay, a fluorine atom has 7 electrons in the outer shell. Figure 8 shows part of a dot and cross diagram to represent a molecule of fluorine. Complete the dot and cross diagram. You should show only the electrons in the outer shell. Please pause your video and try and draw that. Okay, to draw this, work out what group fluorine's in. It's in group 7, so it needs one more electron to get its full outer shell, as does this fluorine. So it means they're both going to share one electron with each other. Now it's worth 2 marks. Your first mark is for putting a cross and a dot, because remember it's a cross and dot to represent where the electrons have come from. A cross and dot in this overlap here to show that these fluorine atoms are sharing. And then your second mark comes from drawing the rest of the electrons in the outer shell. So we know fluorine has 7. One's there, 2, 3. That means somewhere around here you have to draw 4 circles, and somewhere around here you have to draw 4 crosses. If we look at the mark scheme for question 2.2, it should look like that down here. Next question. 2.3. Chlorine reacts with potassium bromide. Complete the word equation. Please pause your video and answer the question. Okay, so this is known as a displacement reaction because you've got potassium, which is doesn't really matter, but you've got bromine and chlorine, and this is showing chlorine is more reactive. So chlorine displaces the bromine from the potassium bromide, and it's just like a normal displacement reaction that you've done before with iron oxide plus calcium, calcium oxide plus iron. So same thing happens here. Just have a look, both your halogens swap. So your single one is just going to be your poor bromine all by itself, and then here it's going to be potassium chloride. So it's displaced it. Question 2.4. What type of reaction happens when chlorine reacts with potassium bromide solution? Please pause your video and answer. Kind of giving you the answer here. It's a displacement reaction. It's not neutralization. You haven't got an acid and an alkali. Precipitation means a solid is formed, and because it hasn't given you a symbol equation, you can't see anywhere that a solid is formed. And decomposition means it's breaking down from one substance into several substances. So it's still 2 for 2 reactants, 2 products. So displacement is the only correct answer. Question 2.5. Complete the box. Choose the answer from. Complete the sentence. Choose the answer from the box. Chlorine is more reactive than bromine. This is because chlorine gains something more easily. Please pause your video and answer. Okay, chlorine gains an atom, an electron, a neutron, proton. You cannot gain or lose protons and neutrons at GCSE because they're stuck in the nucleus. It's not going to gain an atom, it's going to gain an electron more easily. And this is to do with the size of the molecule, it's the atom itself. So if you look at chlorine, it's only got 3 shells, whereas bromine has 4 shells, and it just means that the can gain an outer electron much easier. Question 2.6. How does the size of a chlorine atom compare with the size of a bromine atom? Complete the sentence, choose the answer from the box. Please pause and answer. Okay, may have given this one away as well. If you look at chlorine, it's got 17 electrons. Can't remember bromine off the top of my head. 80, 40, don't know. But because it has less shells, chlorine atom is smaller than a bromine atom. Bromine has an extra whole shell. It goes a bit weird after calcium, but don't worry about that. Question 2.7. Give a reason for your answer. So let's look at our mark scheme for 2.7 and see what they say. Just because the fact it has fewer energy levels or fewer shells, so it doesn't take up as much space. It's not got such a large radius. Question 8. Fluorine reacts with chlorine to produce chlorine fluoride. Balance the chemical equation for this reaction. They've put a little line there for you to answer. Answer and pause. Pause and answer. Okay, so if we have a look, we've got 2 chlorine there, 2 chlorine there, so I don't have to change anything there. This 2 is like a multiplier, so it means you've got 2 lots of chlorine fluoride. So it means you have 2 lots of 3, which means you have 6. Excuse me. So on this side, I've got 2, so I'm going to have to multiply it by 3. So the answer is 3 there. Question 2.9. Explain why fluorine is a gas at room temperature. Use the following words in your answer. Please pause and answer.